everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable equations. So let's get going. Problem solve. X cube d cube plus 2x square d square plus 3xd minus 3 into y equals to x square plus x. So we are given a differential equation with variable coefficients and we are going to reduce this to a differential equation with constant coefficients by making some substitution. And also we are given a Cauchy's equation. Solution. Given differential equation, x cube d cube plus 2x square d square plus 3xd minus 3 into y equal to x square plus x, right? Which is a Cauchy's equation. Now, let's make the substitution. Put x equals to e power z. Then log x to the base e equals to z for x greater than 0. And let theta equals to d by dz. Here theta is a differential operator with independent variable z. Then xd equals to theta and x square d square equals to theta of theta minus 1. Also we can write it as theta square minus theta and x cube d cube equals to theta of theta minus 1 into theta minus 2. We know that theta of theta minus 1 is theta square minus theta, right? Now let's multiply these two. We'll get theta cube minus 2 theta square minus theta into theta is theta square minus theta square, otherwise minus into minus plus theta into 2 theta, which is equals to theta cube minus 2 theta square minus theta square is minus 3 theta square plus 2 theta. Now let's replace x cube d cube by theta of theta minus 1 into theta minus 2 and x square d square by theta of theta minus 1 and x d by theta and replace x by e power z. Then the above equation becomes, replace x cube d cube by theta of theta minus 1 into theta minus 2 plus 2 into replace x square d square by theta of theta minus 1 plus 3 into replace xd by theta minus 3 into y equal to replace x by e power z, will get e power z whole square plus e power z, right? Then theta of theta minus 1 into theta minus 2 is theta cube minus 3 theta square plus 2 theta plus 2 into theta of theta minus 1 is theta square minus theta plus 3 theta minus 3 into y equal to e power 2z plus e power z, right? Then this becomes theta cube minus 3 theta square plus 2 theta plus 2 theta square plus into minus minus 2 into theta 2 theta plus 3 theta minus 3 into y equal to e power 2z plus e power z, right? So here plus 2 theta minus 2 theta gets cancelled. Then this equation becomes theta cube minus 3 theta square plus 2 theta square is minus theta square and plus 3 theta minus 3 into y equal to e power 2z plus e power z. So we have reduced a given differential equation with variable coefficients to a differential equation with constant coefficients, right? Now, and also this is in operator form, f of theta into y equals to a function of z, right? Which is in operator form, f of theta into y equal to function of z, where f of theta equal to theta cube minus theta square plus 3 theta minus 3. Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp. We'll find yc using auxiliary equation, later we'll find yp. Okay? So let's begin with the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of theta, theta cube minus theta square minus 3 theta minus 3. Let's replace differential operator theta by m, so that we'll get f of m equal to m cube minus m square plus 3m minus 3. Then our auxiliary equation becomes m cube minus m square plus 3m minus 3 equal to 0, right? Now, take m square common from the first two terms, we'll get m square times m minus 1, and take plus 3 common from the next two terms, we'll get 3 times m minus 1 equal to 0. Now take m minus 1 common from these two terms, we'll get m minus 1 into m square plus 3 equal to 0, right? Now equate each factor to 0. M minus 1 equals to 0, m square plus 3 equals to 0, right? From m minus 1 equals to 0, we'll get m equals to 1, and from m square plus 1 equals to 3, you will get m square equals to minus 3. Then m equals to plus or minus square root of minus 3. And we can write square root of minus 3 as this minus 3 as minus 1 into 3. Now split square root of minus 1 into 3 as square root of minus 1 into square root of 3. Since we know that square root of minus 1 is I, then we can replace square root of minus 1 as I, or with I we'll get plus or minus I root 3, a pair of complex conjugate, right? Then m equal to 1 and plus or minus I root 3 are the roots of our auxiliary equation. We know that when we have real root, then yc looks like c1 e power, the real root into z. M equals to a plus or minus ib, we'll get yc equals to e power az into c1 cos bz plus, already we have used c1, right? Let's take c2 and c3. c2 cos bz plus c3 sin bz. In case of a is 0, we'll get 0 into z, which is e power 0 into c2 cos bz plus c3 sin bz. Since e power 0 equals to 1, then we'll get 1 into c2 cos bz plus c3 sin bz, right? Which is equals to c2 cos bz plus c3 sin bz. Now coming to m equals to 1 and plus or minus I root 3. So we are given a 1. Therefore 1 is a real root or real and distinct root, and plus or minus I root 3 is a pair of complex conjugate roots. Okay, we know that a plus ib is a complex number, then its conjugate is a minus ib, and if a minus ib is a complex number, then its conjugate is a plus ib, right? So we'll call a plus or minus ib as a pair of complex conjugate roots. When m equals to a plus or minus ib, then we can call it as a pair of complex conjugate roots. Now coming to a complementary function. Complementary function. Yc equals to, firstly let's write for one distinct root or real and distinct root. We'll get c1 e power 1 into z plus, now let's write for a pair of complex roots. Then we'll get c2, just compare plus or minus I root 3 with plus or minus ib, then for b equals to root 3, you will get c2 cos root 3z plus C3 sine root 3 into Z, right? Which is equals to C1 e power Z plus C2 cos root 3 Z plus C3 sine root 3 Z. See, we are having YC in terms of Z, but we need to write in terms of X. So we'll just replace e power Z by X and Z by log X. Then YC becomes C1 into X plus C2 cos of square root of 3 into log X plus C3 sine of square root of 3 into log X, which is our required YC. Let's now find YP. Particular integral. We'll find particular integral using 1 by f of theta into q of z. We are having f of theta and q of z, where f of theta is theta cube minus theta square plus 3 theta minus 3, and q of z is e power 2z plus e power z. We can write this as 1 by theta cube minus theta square plus 3 theta minus 3 into e power 2z plus 1 by 4 theta, theta cube minus theta square plus 3 theta minus 3 into e power z. Now we can find each term separately for our convenience. So this is of, first we will go with the first term. This is of 1 by f of theta into e power az form, right? We have f of theta equal to theta cube minus theta square plus 3 theta minus 3. Now compare e power 2z with e power az. Then for equals to 2, we'll find f of a, which is equals to f of 2. Just replace theta by 2. We'll get 2 cube minus 2 square plus 3 into 2 minus 3, which is equals to 2 cube 8 minus 2 square is 4 plus 3 2s are 6 minus 3, which is equals to 8 plus 6 is 14 minus 4 minus 3 is minus 7, right? Which is 14 minus 7 is 7, non-zero. Since f of 2 is non-zero, so we can replace theta by 2 here. What happens if we get the denominator 0 by replacing theta by 2? We'll get something like this, 1 by 0 into e power 2z. If we get like this, we should not replace theta by 2 because 1 by 0 is undefined, so total term becomes undefined. But in our case, we got denominator non-zero by replacing theta by 2. Okay. This becomes 1 by, just replace theta by 2, we'll get 2 cube minus 2 square plus 3 into 2 minus 3 into e power 2z, which is equals to 1 by 8 minus 2 square 4 plus 3 2s are 6 minus 3 into e power 2z, which is equals to 1 by 8 plus 6 14 minus 4 minus 3 is minus 7 into e power 2z, which is equals to 1 by 14 minus 7 is 7 into e power 2z. See, we are having the first term, the result is in terms of z, okay? And we can just write in terms of x by replacing e power z by x. In order to replace e power z by x, we have to write e power az as e power z whole power a. Then we can write this as 1 by 7 to write e power 2z as e power z whole square. Now just replace e power z by x, will get 1 by 7 into x square. Okay, this is the result obtained from the first term. Now let's go for the second one. See, the second term is of 1 by 4 of theta into e power az form, right? Now compare e power z with e power az. Then for equals to 1, we'll find f of a. f of a equals to f of 1. Just replace theta by 1 here. We'll get 1 cube minus 1 square plus 3 into 1 minus 3, which is equals to 1 minus 1 plus 3 minus 3, which is equals to 0, right? So by replacing theta by 1, we'll get the denominator 0. We'll get something like this. So we should not replace theta by 1 here, because 1 by 0 is undefined, so total term becomes undefined. So we'll just write 1z into 1 by, write the derivative of f of theta. We need to find f dash of theta, which is equals to 3 theta square minus 2 theta plus 3, and find f dash of 1. Okay, we'll get 3 into 1 square minus 2 into 1 plus 3, which is equals to 3 minus 2 plus 3, which is equals to 3 plus 3 is 6 minus 2 is 4, right? Which is non-zero, right? Now just write f dash of theta in the denominator of second step. Since f of 1 is 0, so we'll write 1z into 1 by f dash of theta, that is 3 theta square minus 2 theta plus 3 into e power z. Since f dash of 1 is non-zero, so we'll replace theta by 1. We'll get z into 1 by 3 into 1 square minus 2 into 1 plus 3 into e power z, which is equals to z into 1 by 3 into 1 square is 3 minus 2 into 1 is 2 plus 3 into e power z, right? Which is equals to z into 1 by 3 plus 3 is 6, 6 minus 2 is 4 into e power z, or we can write it as z e power z by 4. Now we are having the result in terms of z, but we need to write in terms of x. So we'll replace e power z by x and z by log x. Then this becomes log x into, just replace e power z by x into x by 4, which is equals to x log x by 4. So this is the result obtained from the second term. So we got results from the first and the second term. Let's replace them in yp. Now coming to yp. So the result obtained from the first term is 1 by 7 into x square, and the result obtained from the second term is, right, x log x by 4. Okay, result obtained from the first term is 1 by 7 into x square, and result obtained from the second term is x log x by 4, or we can write it as x square by 7 plus x log x by 4. So we got yp and yc. Let's now write the general solution. The general solution is given by y equal to yc plus yp. Then y equal to yc, we are having c1x plus c2 cos of root 3 log x plus c3 sin of root 3 log x plus yp plus x square by 7 plus x log x by 4. This completes the problem. So we have seen a problem from higher order linear differential equation with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.